Okay, this is a video on types of reactions, and if you got any questions wrong on types of reactions, you need to take the notes, fix the questions, and then answer the additional questions. Okay, so starting with notes, we have 5 types of reactions. Start by writing these reactions, pause the video if you need to write them, and try to identify the 5 types of reactions that you see here, but this is notes, so here we go. The first one is a synthesis reaction, and what you're always looking for with synthesis is one product. 2 or more reactants and 1 product. In this case, we have 2 elements coming together to form a compound, but it could be smaller compounds coming together to form one larger compound. The next one is the exact opposite. Hopefully you recognize decomposition, so write these down as we go, which is the exact opposite, one large compound breaking into 2 or more pieces. Again, the smaller pieces could be compounds or elements. All that matters is that you start with one compound and you end up with 2 or more products. Anytime you have one reactant in your reaction, it's going to be decomposition. There's nothing else that one reactant can do. He has nobody else to trade anything with. Okay, this third one is single replacement. Now you don't have to draw the silly cartoon, but I do want you to write in your notes that this is single replacement and that its element and compound make another compound and another element. Now it doesn't matter which 2 reactants are listed first, of course, but what matters is element and compound. Now in this case the zinc is the element and the copper chloride is the compound. The zinc kicks the copper out of the compound to bond to the chlorides, and so the new compound is zinc chloride and the new element is copper. Single replacement always has a sad, lonely single guy on both sides. First the zinc, then the copper. But focus on the word element. This could be a diatomic element. It could be H2, Br2, F2. Those still count as single elements. That would not make it double replacement if there's an element that's a diatomic and some other element that could be diatomic, it would still be single replacement. For double replacement, you're always looking at ionic compounds, so it's always metal, nonmetal, metal, nonmetal. And you take the metal of one and bond it to the nonmetal of the other to get the products. And the metal of the second bonds to the nonmetal of the first to get the products. For instance, top hat guy is dancing with hair bow girl. He could dance with ponytail girl. Top hat guy is not going to dance with bow tie guy. Metals will not bond with metals, non-metals will not bond with non-metals. It's always going to be opposites attract. So if you do these outer ones and then the bow tie guy with the hair bow girl, you can see that these are the new couples that you can make. Okay, if you need to pause this, be sure to pause it. This last one is combustion. Pretty much any reaction with oxygen can be called combustion, but this is what you're always looking for. It's usually a hydrocarbon, it uses oxygen, it makes carbon dioxide and water. Think about the combustion of your car. Carbon dioxide and water are what are coming out of your tailpipe. Think about the combustion of you eating food and burning the food at the cellular level. You breathe out carbon dioxide and water, and don't you breathe in oxygen? Okay, so let's fix some of the test questions. If you have what I'm calling version A, then this first question is what type of reaction does this represent? Fluorine's a diatomic, iodine is a diatomic, but they're still elements. So this is compound and element, compound and element. So of course this is single replacement. It's not double replacement. It's definitely not synthesis or decomposition. This is question 14 on the other version. Okay. Here, everything certainly looks double to me, compound, compound, and they trade places. The K can dance with the Cl, the barium can dance with the carbonate. Okay, pairs, all pairs, dancing partners switching places. So number 5 here is double replacement. Now, the way you would fix this is you would fix it on your test, or you would write this reaction and write double replacement. Now, number 5 on test version A is number 17 on the other test. Okay. 8 and 9 are also this type of question. A type of chemical reaction, well, you've got 5 to choose from. It could be synthesis, decomposition, single replacement, double replacement, or combustion. And of course, decomposition is the answer here. This question is actually more difficult later in the year when you've been exposed to a phase change called deposition. The chemical change is decomposition when a compound breaks into pieces. Deposition happens to be gas to solid. These other things are phase changes, or distillation is separation by boiling point. Okay. This question 8 is question 3 on the other test. And this question 9 here is question 4 on the other test. One product. No matter what else is happening, if more than one thing comes together to make one product, it is synthesis. Okay, so there's every question on your test that has to do with types of reactions fixed. And now, this is your new challenge. You're going to write these, pause this video if you need to. You're going to write these reactions and you're going to identify the type of reaction. I am not going to tell you the answer right now. You are going to do this on your own. Okay.